Good morning. In this lecture, we will discuss structure-activity relationship studies of sedative and hypnotic. Structure-activity relationship studies of barbiturate. We know that the barbiturates are the derivative of 2,4,6-trioxohexahydropyrimidine that reversibly depress the activity of all the excited tissues and are synthesized by the condensation of malonic acid derivatives with urea derivatives. CNS depressant barbiturate are mainly 5,5 disubstituted and 1,5,5,5 trisubstituted barbiturate. The main prototype drug in this category is barbituric acid, that is 2,4,6-trioxohexapyrimidine. It lacks CNS depressant activity, but substitution at various positions gives many compounds with sedative hypnotic activity. Structural modification have been done at various positions of barbituric acid and following drugs are obtained like short-acting barbiturate, long-acting barbiturate, intermediate-acting barbiturate, and ultra-short-acting barbiturate. Let's see what will happen when the substitution is carried out at first and fifth position. Both the hydrogen atoms at fifth position replaced by alkyl group or aryl group so that drug can easily cross the blood-brain barrier, for example phenobarbital. Branching of alkyl chain at fifth position increase the lipid solubility with shorter duration of action. Higher the branching, greater will be the potency of the drug. For example, phenobarbital is more potent than amylobarbital. Substitution of methyl group at first position increases the lipid solubility with shorter duration of action. For example, methyl phenobarbital. Total number of alkyl group at fifth position must be in between 4 to 10 for maximum potency. Beyond that, CNS depressant action decreases and drug may act as anticonvulsant. Shortening of alkyl chain resists oxidation of the drug and it acts as a long-acting drug, for example barbitone. Substitution to both N1 and N3 by alkyl group eliminate sedative action of a drug. Means when the substitution at N1 and N3 position is carried out by alkyl group, it will eliminate the sedative action of the drug. Next, substitution of polar group like hydroxyl amino aldehyde into alkyl side chain at fifth position will reduce hypnotic activity of the drug. Isosteric replacement of oxygen at second position by sulfur gives thiobarbiturate having increased lipophilicity and shorter duration of action. Drug will have increased CNS depressant activity and known as ultra short acting barbiturate, for example thiopentane. Isosteric replacement of oxygen at position 2, 4, 6 by more sulfur atoms abolished or reduce the hypnotic activity of the compound. Next is the structure activity relationship studies of benzodiazepine. We know that benzodiazepine has sedative, hypnotic and anti-anxiety, anticonvulsant and muscle relaxant properties. They are most widely used as anxiolytic drug and to treat anxiety, insomnia and a range of other conditions. At low dose are useful as sedative and at high dose produce hypnotic effect. The basic structure of benzodiazepine is shown here. The following drugs are obtained by the various substitution at R1, R2, R3, R7 and R2 position. This is the basic structure of benzodiazepine ring. The several substitutions have been made to the basic skeleton of benzodiazepine to get various compounds. Here skeleton means the basic structure of the benzodiazepine. In the ring A, an electron withdrawing group like chlorine, bromine, nitro and nitrile at 7th position increase the activity. For example, flurazepam means when an electron withdrawing group is substituted at 7th position, it will increase the activity. Next, small group like methyl, ethyl attached to the nitrogen atom at 4th position in the ring B, it has optimal activity. Means when methyl and ethyl or small group will attach at 4th position, it will have the optimal activity like flurazepam. The replacement of the carbonyl function with two hydrogen at second position gives metazepam, which is very less effective. Introduction of a carbonyl function group at the third position increases the duration of action and also favors formation of water-soluble salt. Saturation of 4,5 double bond reduce potency. A phenyl substituent at fifth position increase activity if the phenyl group has electronegativity substituent like chlorine and fluorine at the ortho and diortho position, activity will improve. Thank you. Next lecture we will discuss the synthesis of some selected drug.